Example 8. Write a formula for the graph shown. A transformation of the toolkit square root function. The graph of the toolkit function starts at the origin. So this graph has been shifted 1 to the right and up 2. In function notation, we could write that as h of x equals f of x minus 1 plus 2. Using the formula for the square root function, we can write h of x equals square root of x minus 1 plus 2. Note that this transformation has changed the domain and range of the function. This new graph has domain, close parentheses 1, infinity, open parentheses, and range, close parentheses 2, and open parentheses, infinity. Reflections. Another transformation that can be applied to a function is a reflection over the horizontal or vertical axis. Example 9. Reflect the graph of s of t equals square root of t, both vertically and horizontally. Reflecting the graph vertically, each output value will be reflected over the horizontal t-axis. Since each output value is the opposite of the original output value, we can write v of t equals negative s of t, v of t equals the negative square root of t. Notice this is an outside change or vertical change that affects the output s of t values, so the negative sign belongs outside of the function. Reflecting horizontally, each input value will be reflected over the vertical axis. Since each input value is the opposite of the original input value, we can write h of t equals s of negative t, h of t equals square root of negative t. Notice this is an inside change or horizontal change that affects the input values, so the negative sign is on the inside of the function. Note that these transformations can affect the domain and range of the functions. While the original square root function has domain, close parentheses 0 to infinity, open parentheses, and range, close parentheses 0, infinity, open parentheses, the vertical reflection gives the v of t function the range, open parentheses, negative infinity, 0, closed in parentheses, and the horizontal reflection gives the h of t function the domain, open parentheses, negative infinity, 0, close parentheses. Reflections. Given a function f of x, if we define a new function g of x as g of x equals negative f of x, then g of x is a vertical reflection of the function f of x, sometimes called a reflection about the x-axis. If we define a new function g of x as g of x equals f of negative x, then g of x is a horizontal reflection of the function f of x, sometimes called a reflection about the y-axis. Example 10. A function f of x is given as a table below. Create a table for the function g of x equals negative f of x. And h of x equals f of negative x. For g of x, this is a vertical reflection. So the x values stay the same and each output value will be the opposite of the original output value. For h of x, this is a horizontal reflection, and each input value will be the opposite of the original input value, and the h of x values stay the same as the f of x values. Example 11. A common model for learning has an equation similar to k of t equals negative 2 to the negative t plus 1, where k is the percentage of mastery that can be achieved after t practice sessions. This is a transformation of the function f of t equals 2 to the t power, shown here. Sketch a graph of k of t. This equation combines three transformations into one equation. A horizontal reflection, f of negative t equals 2 to the negative t power, combined with a vertical reflection, negative f of negative t equals negative 2 to the negative t power, combined with a vertical shift up 1, negative f to the negative t plus 1 equals negative 2 to the negative t power plus 1. We can sketch a graph by applying these transformations one at a time to the original function. The original graph, horizontally reflected, then vertically reflected. Then after shifting up 1, we get the final graph. K of t equals negative f of negative t plus 1 equals negative 2 to the negative t power plus 1. Note, as a model for learning this function would be limited to a domain of t greater than or equal to 0, with corresponding range, close parentheses, 0, 1, open parentheses. Try it now. Given the toolkit function f of x equals x squared, graph g of x equals negative f of x, and h of x equals f of negative x. Do you notice anything surprising? Some functions exhibit symmetry, in which reflections result in the original graph. For example, reflecting the toolkit functions f of x equals x squared, or f of x equals absolute value of x about the y-axis will result in the original graph. We call these types of graphs symmetric about the y-axis. Likewise, if the graphs of f of x equal x cubed or f of x equals 1 over x were reflected over both axes, the result would be the original graph. We call these graphs symmetric about the origin.